Okay, this is problem 2 from the foldable that we made in class. We have a group of friends is launching water balloons. The function f of t equals negative 16t squared plus 80t plus 5 represents the height in feet of the first water balloon t seconds after it's launched. The height of the second water balloon t seconds after it's launched is shown in the graph. Which water balloon went higher? So again, since this is a word problem, we want to start by identifying our variables. F of t, it says, is the height in feet of our water balloon, t seconds after it's launched, so t is time. Now, if we look at these other numbers, we know that the negative 16 refers to gravity, the 80 feet is the initial velocity, and 5 feet is the initial height. Now, we want to know which water balloon went higher, so we need to know the maximum height for f of t equals negative 16t squared plus 80t plus 5. We know that if the water balloon went up and came down, that its maximum height is the same as its vertex. So we're going to find the axis of symmetry first by doing t equals negative b over 2a. So negative 80 over 2 times negative 16. So that's negative 80 over negative 32, which simplifies to 5 over 2. So t is equal to 5 over 2, or we can say it hits its maximum height at 2.5 seconds. We want to be sure that we're paying attention to the variables and what their units are. Now, they asked for which one went higher, and this is time, so now we need to find the height. So we're going to plug our 2.5 seconds in to the original equation in order to find the height. So f of 2.5 is going to be negative 16 times 2.5 squared plus 80 times 2.5 plus 5. So this gives us negative 100 plus 200 plus 5. So f of 2.5 is 100 plus 5, 105, and its height, so feet. And we want to note that's our maximum height. So this one starts at 5 feet. It hits a maximum height of 105 feet at 2.5 seconds. Now we come to our other graph, and we're looking for that maximum height right there. Well, check our scale. That's 50. So 25, 50, 75, 100, 125. And it looks like it goes a little over 125. So our second water balloon went higher. So what we did here was, since we needed to find the maximum height, was we started out by finding when it reached its maximum height, which is at 2.5 seconds. And then we plugged in that 2.5 to figure out what the actual maximum height was. Then once we knew that, we could compare it to our second graph.